Here we go.
Good morning, everybody. Welcome to our new webinar, Extending DevOps Practices to SQL Server Databases. Welcome to this webinar brought to you by Redgate. And I am Steve Jones, and I'm going to host the webinar, and then have Arneh here from Redgate that's going to do all the demos and talk a little bit about the details. My contact information is up there. Some of you may know me. I run SQL Server Central, and I travel around speaking and writing about DevOps and databases and SQL Server for Redgate. And I've been doing this for 25 years now with SQL Server, 26 years almost now. So a lot of experience and a lot of fun, and I really enjoy the DevOps thing now, and I'm glad it's finally catching steam. So my partner, Arneh Eskandari, is a sales engineer with Redgate. Arneh, you want to talk about yourself for a minute?
Absolutely, yeah. So my name is Arneh. I've been with Redgate for just over 6 years now, mostly as a sales engineer working with our either new customers or existing customers to help them move towards DevOps best practices on the database side of things, and help them with the implementation of our DLM solution. So here are my contact details. So if you have any questions after the webinar regarding any of our tools, then feel free to reach out.
All right, thank you, Arneh. So our quick agenda, I'm going to talk a little bit about kind of Redgate and DevOps, and just try to level set a little bit about where the industry stands today, so that we're all kind of on the same page. And then Arneh's going to take over and kind of do a demo, and we're going to try to spend most of the time in the demo here today. And please feel free to ask questions. A couple housekeeping items. We are recording this webinar, and so we'll have a recording available probably either at the end of this week or early next week, and everybody should get an email with that. We also have in the GoToWebinar control panel, there's a questions item in there. There's a little place where you can ask questions. So please feel free to ask questions there, and we'll try to get those answered either in text or in verbally. We'll do this. So let's get started. So Redgate is sponsoring this. Both Arneh and I work for Redgate. Redgate is a company that builds software tools to really help you build software. We build tools for SQL Server and .NET and the cloud, and lots of companies, a lot of the large companies use our tools, and they find them very valuable, and they improve the efficiency of their developers. But Redgate, more than just selling software, we also believe in supporting the community. So in addition to these webinars, which are kind of focused on Redgate tools, we do a lot of work to support the community and educate the community as well. We run the Simple Talk and SQL Server Central websites. We support those completely, and they're free sites to help you learn more about SQL Server, more about your job, and we publish information there all the time. So there's a lot of challenges with integrating your database in the DevOps process. I've been studying DevOps and doing.
I just ran the poll to see.
Oh, okay.
How many of our audience are familiar with Redgate tools. So.
All right, so let's look at it for a minute. Take a minute and vote, everybody, if you would, and see what you're using. It seems like lots of people use SQL Compare, which was actually our first tool, and when that was released back in 2001, it was my first customer at SQL Server Central was Redgate, so that's good to see. And lots of SQL Monitor, that's kind of neat. SQL Source Control, good.
Yeah, it looks like there's a lot of SQL Source Control users, which is great.
Yeah, good. So hopefully we'll have you some tips. If you've got questions about things, please ask. Let us know. All right. So we've closed that. We've got a couple more polls we'll run here and there, but for now, let's move forward. Now, I've been kind of doing some of these software development practices for most of my career. Things that we call DevOps now were just either best practices or good ideas or different things that I've done throughout my career. And as much as I've kind of studied the last 5 or 6 years how people are talking DevOps, and we're trying to expand these practices to more people, most of the very well-known people doing DevOps work tend to ignore the database. They focus on the application, whether it's .NET or Java or Python or something else, that front-end work. They forget about the database, and the database is difficult because it does manage state. Our tables have to be maintained. I can't lose that data, and in essence, I have to transition my tables and my stateful objects from one state to the next as I want to deploy new changes. So that's important, right? That data is critical, and if we could get rid of it and rebuild it every time we deploy it, it would make our lives easier, but the business people don't love that. So that's fundamentally the biggest challenge with incorporating the database, is that we have this state and I can't just drop and recreate things. Now, when I'm trying to go faster, or I'm trying to be more agile, or I'm trying to be more responsive to customers in my development, the database has some issues if I don't manage it well, right? And a lot of times what happens is the database lags behind there or it holds back application development because we're really developing on the platform and we're not developing in files like we do with most application software. We lose some of the traceability and tracking of what things we're doing and how we roll back and what code we even had out there. And this creates a bottleneck. And so a lot of people struggle with databases. And we've seen a lot of people move to NoSQL databases because the state is not as important there because they are schemaless, in essence, on write. And their code is all either JavaScript or Java or something. And so they manage it just like application code. And that's fine. NoSQL databases work great, but there are plenty of places where a relational database is a better choice and it works better. So we're really trying to help get the database to move and react just like all of our application code. And then we want to try to reduce the risk of our releases. We don't want there to be problems with the database because that's often, the single point of connection and source of truth for our information for our customers. So when we start to get nervous about database, we slow down development, our releases become less frequent and they become bigger with more changes, which inherently has more risk. And so we're trying to reduce that. And then the other thing we're trying to do is reduce the manual work that's required to produce database development. And sometimes in my career, every time we go to release, a database administrator or sysadmin or developer has to put together this big script and try to ensure they have all the correct changes. They're all bundled together. They're not going to cause any issues. It eats up a lot of time, and it's easy to forget things as I moved from environment to environment. If I move to QA and then I have to move to production, I might make mistakes. So we're trying to avoid all of these issues. And what Redgate has done with trying to do database lifecycle management and the DevOps process expanded to databases is make everything more repeatable and reliable, reduce the manual work, and try to make more automation take the place of what we do. Now, the automation should be just what we used to do manually, but we're trying to ensure that we encapsulate that in some sort of programming or scripting so that it works. This should allow us to have more confidence on releases, to release faster to the business needs, right? Release as much as the application, and release smaller changes every time that we want to do. We should have greater reliability, of course, by having more testing. I don't want to delve too much into testing, but I do believe testing is hugely important, and we have some Redgate customers that test extensively, and they really have a much smoother development process, no issues. So every year, Puppet Labs does a State of DevOps report, and they primarily focus on application software. They're starting to get into security, starting to get in databases a little bit, but what they tend to find is that companies that move into a DevOps world, and which isn't well defined, right? It could be automation, it could be infrastructure as code, it could be CI, it could be CD, it could be a variety of different things, and it's implemented in different ways from different people. But when you're starting to move and embrace these concepts of DevOps, you tend to be more agile, you tend not to waste time, you tend to deploy code more frequently to meet business needs, you tend to have many, many fewer failures in your deployments. Your customers are happy, you're getting code out to them that they can actually use, and you tend to have a more profitable, productive business that has a higher market share because it's easy to just not do these things and expect your employees to kind of react and deal with whatever comes up and move slower. It's harder to get started in DevOps. Once you get going, it actually results in a smoother process. So what can Redgate do here? So on the screen, you should see we've got kind of this development flow process, and it's kind of this pipeline, this linear thing, but really at every stage we're providing feedback. So in essence, part of the idea of DevOps is that we're actually moving in a circle. We're trying to go, get all this feedback from downstream areas, whether that's QA, whether that's customers, whether that's our monitoring systems, anywhere we want that feedback. And so on the left-hand side, we have developers that would be writing all our code, and ideally they're working on their own environment and their own database. And we don't care if you use Visual Studio or Management Studio or something else. Redgate has some tools that plug into platforms. We have prompt and source control and test that kind of help you develop in a better way. And then we want you to save all your code in version control or source control. So few people do that for databases, though they often do it for application code. And we built SQL source control to kind of help you do that. And then there's various ways you can do it, but ideally we want you to use some sort of version control, capture all your changes. And we don't care what version control system you work with, right? We plug into all of them. even more than are listed on the screen. But we want you to use that, and then from there, introduce some automation and some consistency to your process. And we do that in software typically with a continuous integration process where every time a change commits to version control, we rebuild our software. In this case, we rebuild our database, and then we test it and try to determine if it's working the way we expect it to work, right? Whatever our needs are. We provide feedback to our developers, and if everything is working great, then we have a package to deploy. And again, we plug into Visual Studio Team Services, TFS, TeamCity, Jenkins, Bamboo, Cruise Control, Hudson, Go, whatever system you want to use there, we'll plug into it. And from there, once we've got a package, we want to have a consistent release process. So we have the DLM automation, and we work with all the release servers out there so that you can have a consistent way of releasing your database software. So when I go to testing or QA or UAT or staging or any of those environments, I always package and release the software that changes the same way. And then that's the same way I deploy to production as well. And then finally, we're kind of stopped there today, but we don't want you to forget about monitoring your production systems and being aware of the impact of your changes as well as the performance and availability and everything else. And I've kind of walked through some of this, I think, so I won't delve in there too much. But why don't I turn this over to Arneh, and let's go ahead and make this a demo and go from there. Sound good?
Awesome. Thank you so much, Steve. All right, so let me go ahead and share my screen here and make sure everyone can see it okay.
Yep, now I see it.
Okay, perfect. So today we're going to be focusing on how you can utilize Redgate tools alongside TFS to manage, your database changes and in source control, and be able to also validate those changes as part of an automated build process and be able to deploy them to your hiring environments as well. So TFS has come a long way over the past year or so as far as making it really easy for you to implement your whole end-to-end process, starting from source controlling your changes all the way to releasing changes to higher environments across your application. So we're going to be showing you how you can do that as part of the latest version of TFS. So I'm going to be using VSTS, which is the online version of TFS, but the same features that we're going to show today applies to the on-premise version of TFS as well. So we're going to be focusing on how you can utilize TFS work items to keep track of the stories that you will be working on as part of your agile development process, and how you can use branching in TFS Git to manage your stories and to be able to create isolated source control environments for you to work on until you're ready to deploy those changes and you merge your changes then into your main branch. So we've seen a big uptake in terms of number of Git users over the past couple of years, and I think that's mostly because of how easy it is to take care of branching and merging in Git in comparison to other source control systems. So you'll see a bit of that as well as part of our demo today. So so the databases that we'll be working with today is the AdventureWorks database. So here I have this database that represents my development environment that we'll be making changes to. And then we also have a couple of other environments here that we'll be deploying to. So here you can see I have this UAT staging and production environments that we'll be deploying our changes to. A lot of you might be working with databases that are being utilized by multiple applications. And one thing that I do hear a lot when talking to customers is when working with a database that is being shared across multiple applications or projects, they normally have different release timelines. And as a result of that, the changes that you make to that single database, would need to go at different times or different release timelines. So how do you keep them isolated? And, especially with the whole continuous integration movement where you want your source control to be the source of truth, how do you specify what is ready to go from source control and what is not ready to go? So again, we'll show you how you can manage that through a branching strategy in Git when you deal with, when you're working those type of situations. So the database that I'm going to develop against is this AdventureWorks Git database. You notice my database icon is green. So for those of you who spend a lot of time in SSMS, then you know that the default color of your databases is always yellow. So the ones that are green here are the databases that have actually linked to source control through our SQL source control plugin. So what you see here in the middle is our source control plugin, which acts as a bridge between your development databases in SQL Server and an existing source control system, whether it's Git in TFS or the centralized model in TFS or Subversion or any other Git servers that you're working with. You can just simply go ahead and link your databases to those. So my database here is already linked to my source control repository. So we're using Git, and obviously the workflow with Git is that you commit your changes locally into your local Git repository on your own machine. And then when you're ready, then you push those changes across to a shared server or remote server. So in this case, my Git is repository sitting in this location on my machine that I will be committing my changes to. And then from there, I will push my changes to go into TFS. So since this is an existing project, and that means we already have a copy of our database in source control. So if I go into TFS, just to quickly show you what that folder structure looks like. So if we go to our files here, so the way we store your databases in source control is by breaking your objects down into these individual folders. And then for each type of object, we store the create scripts of every single object that you have in your database. And as you modify changes or modify objects, then we go ahead and update the create script of that object in source control. So that way you can see, you can get a history of how specific objects or individual objects have changed over time. And when it comes to doing the deployment, what we do is we compare the state of your database that is in source control, so all these create scripts that we have for your objects, and even insert scripts for your configuration tables, your lookup tables, and we compare that against the higher environments later on to figure out what differences exist between source control and your target environment, and based on that, we generate the actual deployment script that you would need to run to synchronize your target environments to match what you have in your source control repository. So now let's go ahead and start making some changes. The first thing that I actually want to do is to create a new user story. So we're going to be working on a new feature, and in order to do that, I'm just going to create a new work item, and that work item is going to be a user story. Okay, so I'm just going to go ahead and add a title for this work item. So let's call this Make AdventureWorks Great Again. How about that?
Sounds good.
So let's go ahead and just assign that to myself so I can contribute to this work item here. And I'm going to go ahead and save this. Okay. Let's go ahead and refresh that. Now, one thing you notice, so my work item got created. It's work item number 16. And here you can see it actually gives me an option to create a new branch for this work item specifically. So if this work item is assigned to me as a developer or a number of developers, then what you can do is that you can create an isolated branch that those developers or you individually can work on as far as that work item is concerned. And once that work item is complete, then you can go ahead and merge your branch back into the master, which means that then it can get built and get deployed to your higher environment. So I'm going to go ahead and do that. So I'm going to create a new branch here, and I'm going to call this Dev Arneh as my branch name. And you can see it's linked to this work item that we'll be working on. Okay, and we're getting the latest version from our master branch, so everything that is in master is going to go into this Dev Arneh branch, and then we're just going to continue contributing to that specific branch as far as our development changes are concerned. So let's go ahead and create that branch. So my branch got created. So now I need to bring this branch down to my local repository. So you can either use the Git command line or a Git client tool such as SourceTree. SourceTree is one of my favorites, so I'm just going to use SourceTree to bring that branch down to my local. So I'm going to pull from the origin. And here you'll see it will show that there is a new branch here now, dev Arneh, and I'm going to check this out so I can start making changes to this branch. All right, so now you can see I'm on the dev Arneh branch. If I go into source control and visit my commit tab, you can see that it now shows my current branch here at the top right corner as dev Arneh. So I'm on the right branch now, and I can start making changes to the development database and commit my changes into that specific branch that we just created. So let's go ahead and do that. So currently there is no, as you can see, there is no changes to commit to source control. So I'm going to go ahead and make a couple of changes here. So I'll start off by making a store procedure change. And as we go through the demo, I'll be using some additional tools from our SQL tool belt, including SQL prompt, which is what you're seeing here, which is our productivity tool that makes it really easy and effortless for you to write your SQL in SSMS. So I'm just going to go in and specify the additional columns that I want to add to this statement here. Okay, that looks good. I'm also going to go ahead and format this to make it more readable and nice, and make my change here. As you make changes to your database objects, SQL Source Control will display these blue blobs next to the objects that you're modifying. So it's a visual indicator that you have some changes, or these objects are now different from your source control repository, so you need to commit those to source control. Before I do that, I'm also going to make a data change to one of my lookup tables. So as part of SQL Source Control, you can specify which tables you want to source control in terms of data, and using this link or running static data option here. So this will give me a list of tables that we have in our database, and from here you can select which tables are considered as lookup or configuration tables. And what we mean by lookup tables is tables where you would make data changes to in your development environment, and you push the same data all the way to your production environment, and that data doesn't get changed in production as a result of your end user's interaction with the application. So here I have one table contact type that I'm source controlling in terms of data. So I'm going to make a data change to that table as well. So let's go ahead and do that. So I'm going to insert a new record into that table. So contact type, and let's call this new contact type the TFS work item webinar audience. Okay, that looks good. All right, so made a couple of changes. I'm going to go ahead and commit these changes. So it's always a good idea to commit your changes frequently to source control. So I'm going to commit these two changes here, and I'll make another change and do another commit into my dev branch before we're actually ready to build and deploy those to our next environment. So the commit tab will show you what objects and data is different from your development database against your source control repository. So here you can see the contact type data is different. So here at the bottom you can see it's showing a bunch of insert scripts that represent the data that sits in our development table or the contact type table in our development database. And on the right side is the data that's already inside our source control repository. So everything is identical except that new one that we just added, as you can see here, for the TFS work item webinar audience. So that's going to get added to our source control. And if you click on the USB get contact store procedures, again, you can see exactly what's different. So for those of you who are familiar with our compare tool, then this is very similar to what you see in compare when you're deploying your database objects, and before you do that, you can see exactly what's different going from your source to the target. So in this case, our source is our development database, the target is our source control repository. So I'm happy with these two changes. I'm going to go ahead and write my check-in comment here. So we added a new contact type, and we modified the USP. Oops.
Yeah, go ahead and type, Arnie. By the way, when you're writing these comments, write the comments why you did something. I know we're just kind of doing what we did, but ideally you want to write why you did this.
Exactly.
And we don't want to write. We don't want to write because of the demo, right?
Right. Exactly. Yeah. Okay, so that should be good enough for the purpose of the demo. So I'm going to go ahead and commit this into my repository. Again, this is just going to my local. For those of you who are new to Git, it's just going into my local repository. No one can see my commits until I've actually pushed those to TFS. So before I do that, I'm going to make another change real quick, and I'm going to make a table change. So let's say we want to add a new column to one of these tables. I'm just going to use the designer to do that. So let's say that the new column that we want to add for these errors table is the console output from the error. Okay, and I'm going to commit that separately into source control. So I'm going to change this to source control again. Okay, so as you similar to what you saw with the previous commit, again, we can see here at the bottom what's different as far as our source and the target. And here we can see that the new column is missing from source control, so it's going to get added to the definition of the table in source control. So added a new column for console output to make the error log more visible. Okay, go ahead and commit that as well. Now, now let's say that I made all the changes that was required for this specific work item. So now I need to get those changes across to our TFS server, and I would also need to merge those changes back into our main branch or the master branch, so that way it gets merged into our existing code base, and then from there it gets built and deployed to our target environment. So the next thing that I need to do is to push my changes to TFS. So you can see here it gives me this push option. So I can go ahead and push from here to the same branch in my TFS repository. So it's now getting pushed to the dev Arneh branch in TFS. And once that's done, then I can go ahead and merge from my dev Arneh branch to the master branch in TFS. So there's two ways that you can do this. The best way to do it is through pull request. So here you can see I have the option to create a pull request. So I'm going to create a pull request to bring the changes that I just made to my branch into the master branch. So I'm going to say create a new pull request here. And we're going from our dev Arneh branch into the master branch, which is the trunk, basically. So at the bottom here, it shows us exactly what files are going to be affected and how. So this is basically doing a diff between my dev branch and the master branch to show me exactly what objects or what files are different and how. So, you can see that the contact type data, we have that new data that we added that is going to get added, how the USB get contact store procedure is being modified, and finally how the errors table is getting modified as well, where we added the new column. So everything looks good here, so I'm going to go ahead and create my pull request. And again, you can see because our branch was created off of the, our work item, then everything is linked to that specific work item. So it makes it really easy for you to track back to that specific work item as far as your merges or even commits are concerned. So let's go ahead and create this. Normally, it's a good idea to have, someone responsible for approving the changes, but that's not a requirement. So you have the option to just go ahead and do a pull request without anyone approving. But in this case, I'm just going to approve it myself. and complete it, so that way it merges the changes into our master branch. So let's go ahead and complete the merge. And now our master branch is updated. So if I just quickly go back to our code,
We see that merge.
Yeah. You can see the changes that I just made. And we can see also the branch updates as well.
All right, great. Hey, Arnie, let me pause for a minute. Let me launch our version control poll. So if everybody could just let us know we're just curious what version control systems you use, because it helps us, determine which resources there are and try to understand what, what's important to everybody out there, right?
Sounds good.
So yeah, so a lot of TFS today.
Yeah, exactly. So far, it looks like almost 80% use TFS.
Yeah.
Which is good, because
yeah,
that's what we're focusing on.
Exactly. So let me ask you a couple of questions, Arnie, while it's here. So somebody's asking, how does our data source control scripts get updated with schema changes? So, if you had a new field to contact types, how would we deal with that with the data side?
So if we're just so I understand the question, so if we're adding like a new column and we also need to populate that with data.
Yeah, so I think like contact types might be one of those lookup tables, right? Static data tables. Correct. You use.
Yeah. Yeah. So if you're making schema changes where it also will require some data changes to go with it, then what you can do is you can utilize the migrations feature of SQL source control to basically, so basically what migrations is, you have two options here as far as what migrations is concerned. You can either do just data-only migration scripts, so if you want to do data fixes in your higher environments that doesn't really touch any object schema, then you can start with this blank script and provide your migration scripts through that. Or you can, if you've added, let's say, a new column to a table and you've populated that table with some default, that column with some default data, then for those of you who've used compare, then you know that compare has no way of reading data. So all it sees is that there is this new column that it's been added, but it will not know anything about the data. So what you can do there is you can replace that behavior of compare by providing a migration script associated with the specific object. So in this case, we don't really have any changes, uncommitted changes or pending changes where we can generate a migration script for, but this is what you would use to provide that specific script where you actually add the column as well as the update script or the insert script to update the columns with some default data. And that's the script that compare will run when it tries to deploy your team.
All right. Sounds good.
All right. So again, you can see, you can easily see, the branches that you worked against and when you did your merges. So here's where we did a merge request just now, and it merged from dev Arneh to master. So you can see exactly what commit got merged as part of that process. All right. So now, when we do a merge into master, that normally triggers a build in our CI environment. So if I go to the build tab of TFS, here you can see that we just had a successful build that ran 4 minutes ago, and the build was successful. So, and that was as a result of the merge that we did to master. So, and you can see that here. Now, let me quickly walk you through what we're doing, what the build means for databases, right? So we know that on the application code side, it's as simple as just recompiling your project, whether it's Java, you use Maven, or MS Build for .NET or any other type of languages that you might be working with. But what does it mean when it comes to databases? Obviously, there is no compiling when it comes to databases. So how do you produce mimic that process for your databases. So let me go to the build definition that we have set up here for our database and quickly show you what steps we have in place to for our build. So as part of our SQL tool belt, we have a component called DLM automation, which mostly takes care of automating your build and release process of databases changes as part of an existing CI environment, whether it's TFS, TeamCity, Jenkins, Bamboo, or any other CI or CD frameworks that you might already have in place or you might be already using for your application code, then this nicely plugs into those technologies. So in this case, we have this extension as part of our DLM automation specifically for TFS, which is what you're seeing here. So the build AdventureWorks is using the Redgate DLM automation build extension. And if I click on it, here's what it looks like as far as the configuration build. So what this build step does is it tries to create the schema of your database, so all your objects that you have in source control, specifically in the master branch in this case, from scratch on a temporary database. So that's how we try to recompile your database to make sure that all of your objects are valid, that there is no broken dependencies or any SQL Server completion or syntax errors. If we can build your database from scratch on that temporary database, then that means that our schema validation was successful. So that means your database can be built from scratch successfully without any issues or errors. And that's just to make sure that we're following the principles of continuous integration, because continuous integration focuses on making sure that your application can be compiled as a whole. So it doesn't matter if you just put 2 changes in there, it still wants to recompile everything to make sure that the two changes that you made didn't actually break anything else as far as your application code is concerned. And we're trying to do the same here for your database. So once that database build is successful, then what we do is we package up the database files from source control into a NuGet package. And that NuGet package can be used as the source of deployment or the artifact of deployment when you're looking into deploying your changes to your next environment. So far we haven't done any deployment. All we've done is that we've validated the state of the database that is in our master branch to make sure that it can build successfully. And then if from there we can look into deploying what we built to our higher environment. So as part of this process, you also have some additional operations that you can utilize. So there is a test operation that you can use to run some automated tests on your database using T-SQL-T. And we provide our SQL test tool as part of the SQL tool belt, which you could utilize to add those unit tests or the code analysis tests to your database that you're working with. And you can commit those tests to source control. So for instance, here you can see I have a bunch of SQL comp objects, which are stored procedures. And these are SQL comps, just like .NET Comp is a code analysis testing framework where you can, run some tests to make sure that you're following best practices of, as far as naming your objects is concerned or scripting your objects, or even some performance tests such as finding fragmented indexes and those type of things. So if you have any of these tests and you've committed them to source control, then you can utilize that test operation that we have here to run the test automatically. So so that's what we do as part of the build process. So you saw our build was successful. So if I go back to my builds here, so build number 45 was the most recent one that got triggered as part of the merge that we did into master. And here in TFS, I actually have the option to create a new release off of this build using this option here. So let's say that we want to actually deploy this build to our higher environment, which includes these commits from, in this case, it's just from me, but you'll see exactly which developers contributed to this specific build and what's included as part of this build that you're now trying to deploy. So the user story is there. The commits are there. Everything is nicely visible as far as what you're deploying now to your higher environment. So I'm going to go ahead and create a new release of build number 45, which is going to use the NuGet package from this build as the source of our deployment and compare that against our higher environments to do the deployment. So let's go ahead and create this new release. Now let's go to the release tab here. So you can see we just created release number 20, and it actually started the deployment to our testing environment. So we have 3 environments: testing, staging, and production. So let's go ahead and take a look at what we're doing here as far as the deployments are concerned. So we, just like the build extensions, we provide an extension for the deployment side of things that you can install in TFS and use those extensions. So while the deployment is running, you can actually see that it just stopped for a manual intervention for someone to review the deployment before it gets executed. But before we look at that, let me just quickly walk you through the steps that we're actually going through in order to do the deployment. So here are my environments: testing, staging, production. And for my database deployment, what I've done is I've broken down my deployment into 3 steps. So the first step is this perform create step. And what this does is that it runs a comparison between your NuGet package that you're deploying from against the target environment that you're deploying to. And based on that comparison, it generates a report of what objects are being deployed and what differences exist and what the actual deployment script looks like. And typically, especially for your more important environments such as pre-production or even production, it's always a good idea to have a review step for a DBA or someone who normally reviews your deployment scripts or is in charge of generating your deployment scripts, or if you're currently following a manual process, then it would be a good idea to have them just as a gatekeeper to just take one final look at the script that is going to get executed, make sure they're happy with that, and then if they approve it, then we'll move on to the third step, which is the execution of the deployment script. And I follow the same steps for all of my environments in this case. So let's go back to our releases and take a look at the manual intervention. So normally you will receive an email if you have been assigned as a person to review changes. But in this case, because we're already on the UI, then we can see that here. So it's asking me to review this changes.html file in this location. So in this case, it's on my local, but you can use a network share or a shared drive to put those reports on. So let's go ahead and look into that folder here. So here's our project. We're trying to deploy to testing and release number 20. And here's that report. So it's an HTML file. And if you look at the changes tab here, you can see all the objects that are being deployed as part of this deployment. So we're comparing this NuGet package 1.45, which was coming from build number 45, against our target database that represents our testing environment. So here are the objects that are being modified. Again, just using the Git style, we show you how the object definition is different from your source, which is the NuGet package, against the target environment. So here's what's different on the errors table is that new column that we added. And the USB get context store procedure, again, the columns that we added to the select statement. And finally, the data that we added to the contact type table. So, and the warnings tab will let you know if there is any risky changes or changes that could result into data loss, such as tables being dropped or recreated, columns being dropped, or indexes getting dropped. Those you will see as warnings here. In this case, we just have a low warning to telling us that previous deployments had migration scripts, but in this case, we don't have any migration scripts. It's just relying on compare to generate all of our scripts for us. So go to the script here. This is the script that SQL compare generates in order to apply those changes that we are deploying. So you can see here's the alter table to add that new column that we just added. Here's the alter procedure, and here's the insert for that new record that we added to our table. The nice thing about this is, the script that we generate is pure T-SQL. So, like for instance, there's if you look at SSDT, it uses SQL CMD, which includes some additional lines of code in there on top of the T-SQL. So if you wanted to know exactly what's happening as far as SQL is concerned, that would be a bit confusing. But in this case, this is just pure T-SQL that you can even take and execute it directly from SSMS. onto your target environment. And it's easier to read and know exactly what's going on. So everything looks good here. So I'm going to go back and approve these changes to actually get executed on our testing environment. So I'm going to go ahead and put a little comment here and say resume, which is now going to go ahead and take that update script that we just looked at, and it's going to execute it on our testing database. And that will conclude the deployment to our testing environment once the script is executed. We can even look at the logs here to see exactly what it's doing as part of the deployment. So you can see what kind of changes are being applied when you look at the logs of your deployment. Okay, so the deployment to the testing environment was successful. Again, these are the changes that we just pushed out to the environment, and you can see the database update succeeded. Now I can just go ahead and promote this to our hire environment. So I can now deploy that to our staging environment. And again, you can see exactly which work items are included in this, which commits are included in this, and you can even add a comment to specify, if there's any additional notes that you want to include for audit trail purposes. And just go ahead and deploy, and that's going to start a process again. So it's going to go through the same steps that we just went through as part of our deployment to the testing environment. Okay, so that's pretty much the high-level overview of a typical database change management process utilizing our SQL tool belt and TFS, latest version of TFS. For your database change management. So we still have another 10 minutes. So I'd like to spend the next few minutes going over any questions that you might have. So Steve, I don't know if there is any.
Yeah, we got a lot of questions.
Okay, perfect.
So a lot of questions. I've been trying to answer them. Apologies, not quite paying attention. So let me see, what haven't I answered very well that maybe we could go on. So a bunch of people have asked if this is recorded. It's definitely being recorded. So static data, Arneh, is there a recommended size or limit for how much data in static data?
Yeah, we don't have a set number for static data because that really depends on the specs of the machine that you're working with and where your SSMS is installed. But generally, if you're for example, if you're dealing with thousands of records inside the lookup tables, then that might slow down SQL source control a bit or take a long time for your commit to actually refresh. Because what we're doing as part of the data commit is we're running a data comparison between your table where your data sits and the data folder inside your repository. So if I just go back to our code here and show you the files, we have this data folder here. And within this data folder, we store a .SQL file for each table. And then within that .SQL file, we have the insert scripts of all the data that you already have in source control. So when you're committing changes to source control or trying to commit data changes to source control, we run a comparison between the data in your table that sits on your development environment and the data that sits in this location here. And based on that comparison, we figure out what data you need to commit to source control. So if you have a lot of data, then that means that you have a lot of data to compare. So refreshing your commit tag might take longer than normal. So and that really depends on how much data you have. So if you have thousands of lines, records in your tables, then your commit process might take a few minutes to refresh and show you exactly what data differences exist.
Right.
I just normally recommend just go ahead and install it, install the free trial and just try it on your environment, see what kind of performance you will get from the tool as far as data is concerned.
Yeah. So actually, let me kick off the CI poll, and then I've got another couple questions, Arneh, that you can answer. So if you wouldn't mind, I've got a couple of polls that I just want to run real quick, if you guys would answer. So Arneh, somebody's asking about linked servers, and they reference them in store procedures. You got a recommendation for that?
Yeah. So when it comes to linked servers, really the main part where that you would need to, I guess, uh, be wary of is the build process. So because as part of the build process, we try to um, validate every single object and make sure that any objects that those objects reference are valid, then that means wherever you do your build from, whatever server you do your build from, would need to have access to those link servers, or would need to have those link servers defined on that SQL server where the temporary database gets built. For that reason, I normally recommend doing the build either on your dev server or your test server where those link servers already exist. So that way you can go ahead and validate all the objects that are being referenced as part of your link servers or any cross-database dependencies. Other than that, on the development side of things, because you're working with actual databases, there is no project involved, so you can easily just deal with link servers from there. But it's really just the build side of things where you need to make sure you do the build on a server where the link servers can be accessed.
Right, right. And actually, I had someone on Twitter say, just stop using link servers is the correct answer, but I understand for some of you, you need to use them as anything. So somebody else asked, what do you think about your database source control? Do you keep that with application source control separate, single repo, separate repo?
Yeah, so we have some customers who, keep a single repository for the database and, the same repository for both the database and the application code. So it really depends. So if let's say you're a full stack developer who works on both the application code and the database, and that's how your team is mostly structured. So you have people who just do everything across the board. Then for those teams, it's better to just have everything as part of the same repository, because when let's say you want to branch out everything, including the application code, then you just create a branch of what you have in that single repository. So it makes things easier when it comes to branching. But if you have, dedicated SQL developers who just mostly work on SQL and then dedicated application developers, then it might make sense to have two separate repositories. So if the application people want to have a different branching strategy on their repository, they can just go ahead and do that. And if the database folks want to have a different branching strategy or workflow on their repository, then they can just do it on their database repository. So it really depends on how you're set up as far as your team, the individuals, and what would make more sense to you.
Okay. So somebody else asked, do you prefer using sync in the build or in the release step when you're keeping lower environments in sync?
So I would only use the sync step for cases where you have, let's say, dedicated development databases and a shared development or integration database that you want to integrate the changes to. In that case, you would use the sync function. So for those of you who are not familiar with our build steps, we're talking about this build operation here that I showed you earlier. So let me just quickly show that.
Yeah, do that. No, I just closed the poll, so go ahead.
Yeah, so everyone knows what we're talking about here. So inside the build extension, we have this operation called the sync. And the sync really basically just does a deployment to your higher environment. So I would use this to update your lower environments, or in cases where you have your developers working on their own dedicated databases. And then if your build succeeds, that you also want that to automatically sync the changes to an integration database or a shared development database that is being accessed by the application code itself for testing purposes, then I would use the sync function. The reason why I wouldn't use the sync function for deployments to the more important environments, such as your higher environments, is because the sync function does everything in one single step. So it does the comparison, the deployment. Doesn't really generate an artifact of that report that you just saw. It doesn't generate that report. So for that reason, I would rather stick to the release extensions and do the releases properly under the release component, because that generates that report that we saw. You can break your deployment into 2 steps and do manual interventions if you want to. So for that reason, I prefer to use the release for the more important environments and deployment.
Okay. Another question. How do you, so this is one you might want to show in Management Studio. How do you determine which tables you source control data and which ones you don't? I don't know if you showed that, but let's go back and go to that.
Yeah. Yeah, let's show that once more. So when you right-click on your databases that are linked to source control, under other SQL source control tabs, you have the option to link or unlink static data. and this will basically populate this list with the tables that you have in your database, and then from here you just select the databases or tables that you want to source control in terms of data. So when you're adding data for the first time, like let's say we also want to add this address type table, which is another lookup table, this is what the commit tab would look like. So if you're committing data for the first time, it will include all the data from that table in your single commit. So, and this is what it would look like. So there's nothing in source control yet as far as that data for that table is concerned. So it's going to add all those insert scripts under a single .SQL file for this address type table in source control for us. And then I can just go ahead and commit that data. And then from there, if there's any differences between the data that I'm committing now against the target environments, then the deployment will include them. If there's no differences, then nothing will be deployed. All you're doing is just putting the data in source control, and that's it.
Okay. So here's a good one, and it's one that I'm not sure I know how to do it. So if you find errors in the script during the manual intervention or you see something wrong, can you make changes to that script, or what do you do there? You have to rebuild the script, right?
Yeah, I mean, you can make changes to the script, but that's not, we don't recommend that. So the script sits within this location. So this here is that update script. It's just a .SQL file. So if you want to modify it, you can do it. But the problem with that is that it makes it really easy for you to introduce drift into your higher environment. So if you're shifting the schema, the state of your database from what is in source control to a totally different state as a result of the changes that you're making manually to the script, then you're introducing drift to your higher environment. And basically what that means is when you do a release next time, the release will undo any of the changes that you actually manually added into the script. So, and so for that, in order to avoid that, what we recommend is going back into source control or into development, make the necessary changes to fix that, and then commit those to source control and do a new build and go through the same process and make sure that everything looks good at that point. If it's just a minor tweak, for example, like if you see compare making the change in a certain way, and you just want to make a small tweak to get it to do it in a different way, but the output, the outcome is still the same as what we're expecting to get, then yeah, that might work, and you may not have any issues with that. But generally, we just recommend going back to source control and making the right changes to get that script to the right state.
Okay. So somebody asked this, SQL clone be added as steps of DLM. I know you didn't show that, but yeah, we actually do have a plugin for VSTS for clone.
Yeah, so with clone, we have PowerShell commandlet, just like the DLM automation, that you can utilize to say, okay, as part of the build process, we want to create a clone of our production and run a test deployment against that clone to make sure that all these changes that we just made can be successfully deployed to a copy of production. So you can do that as part of the extension and the PowerShell commandlet of our SQL clone tool. And for those of you who are not familiar with SQL clone, it's basically a new technology that we just released a couple of months ago, where you can easily create clones of your existing environment without taking up a lot of disk space, and be able to create clones within a matter of seconds for really large databases. So if you have a 2 terabyte database, your clones will only be at around 100, 200 megabytes in size when you start, and then creating those clones would only take a few seconds. So it's a good tool for doing automation as part of your build process and creating clones and doing test deployments against, as well as helping those shops who are working on a shared development database to go towards a dedicated development database where each developer has their own clone that they can make changes to, and then they merge their changes into the main development database.
Right. I know we're about out of time. Somebody's asking, can we promote to multiple sequences at the same time? That's just adding those to your release steps, just adding copies.
Yeah, so right, exactly. So if you have multiple instances, that means you would have multiple release steps inside your release definition. So you would have one step per database that you would be deploying to. Or another thing you can do if you have a lot of databases is you can run the comparison again one database, as long as the schema is the same across all instances. Then take that script and use the PowerShell of SQL CMD to just execute that script across all servers.
Yeah. Boy, bunch more questions. Do you have to run, Arnie, or are you running out of time?
No, I'm good. Yeah,
Okay.
My schedule is open for another.
So a couple of other things. So somebody asked, does the continuous build check for dependencies on test scripts for changed objects? I assume they mean only testing the changed objects, and we don't have anything to do that. It's kind of a.
So it just as far as dependencies are concerned, we check all dependencies. So any object that you have in that source control repository that you're running the build from, or that specific branch that you're running the build from, we check dependencies for everything, including the objects that have been changed, as well as objects that haven't been changed as part of that specific development process. So everything gets checked as part of the build process.
Okay. Somebody asked, can you build a deployment package for an off-premises database, something that's disconnected?
So you would need to you would need to have some you do some stuff manually. So obviously, in order for the comparison to work, you would need to have a target that you can compare against. And if that target is not available, then you would either need to manually bring back a snapshot of the target of that production environment that is isolated, and then compare against that snapshot to figure out what differences exist, and generate a deployment script, and then take that deployment script that it generates and manually go and execute it on the production environment. Or if you have, or if your pre-production that you have access to is identical to production all the time, so you have a mechanism where you make sure that pre-production matches production, then you can always just do the deployment to pre-production and then take that same script that you deploy to pre-production and execute it against your production environment manually again, because there is no way that you can do it automatically without having any connection to your target environment.
Okay. So what else? Some of these we've already done. So a lot of DBAs don't like generated scripts and they want to see them. Where can you view the output? So we showed this in the manual step, right? You get the chance to review the script, and certainly the script is just captured into file system.
Yeah. So for every deployment that you do, or for every release that we create, we generate that report that you saw earlier, so this changes.html file that we looked at. And in here, we actually show you the script that is going to run in order to do the deployment. And a couple of nice things about this is that you get a nice audit trail of exactly what you've deployed in your previous releases. So here you can see, by simply looking at this report, I can see that this release came from build number 45, because that's how we version our NuGet packages. And here are the objects that got changed as part of that release. Here's the deployment script. And we even provide some additional, files in there. So we have the states of your environment. So we have the source, which is the NuGet package. We have the target, which is the target database that you were deploying to. And, you can utilize this folder structure here. So if for any reason you want to roll back to a known state, then you can always run a comparison against this state here, which is the state of your target environment before deployment. And you can see what script compare generates for that rollback or for that roll forward process. So you have everything basically saved off as part of that create release step.
Right. So somebody says this is for changing databases. What about creating new databases? I mean, we don't create databases, so we don't have that as part of this process, right? But you create a database, and then when you would hook it up to SQL Source Control, it would be empty. So you just then start adding objects. There's no magic there, right?
Exactly.
You're always changing databases.
Yeah, or if it's new databases that you're deploying to, so you already had a database, but you're either spinning up a new environment, then what you could do as part of the release process is to just add a. So we don't. So if the database doesn't exist, then we can't create that database for you. So what you would need to do is to just add a step a PowerShell step as a pre-deployment to which says, if you're using TFS or any other release management tool, then you can just go in and say, execute a PowerShell script. So, and as part of that PowerShell script, you can put a check, say if database doesn't exist, and go ahead and create it, and then go through the deployment process. So, but we don't have anything built inside our components to create the new database. So
right. So, I mean, in that case, what I would honestly say is you need some sort of script that creates a database that understands pathing and sizes and all the things that you may care about. And you just make that either a SQL command or PowerShell or whatever as a step, and with logic that says if it does not exist, then do something. If it exists, do something, right? That's how you really handle that. So I don't know. There's a couple of questions I think you answered there, but they all start to diverge a little bit. So let's just flip back, Arnie, and stop for now, and then I'll answer some questions when we close this off. So how do